Okay, ji, let's wait for 2 minutes so that the rest of the students they can join. Wait for 2 minutes. Okay, ji. So what we have seen now that we can make the groups. We can make the groups, and the horizontal groups can be either group of two, or we can have a group of four as well. We will see in the next example that how we can have the horizontal groups as well as the vertical groups. Okay, the next example is, let's suppose we have a function. We have a function, let's suppose f is equal to x complement y and z plus x y z plus x y z plus x y and z with x y complement z complement and plus x y z and plus x y z complement, right? Now with this function, what we can see that again, as we have three variables, so this means a total of 8 boxes will be required to map this function with x over here, y z over here, x is 0 1, y is 0 0 0 1 1 1 and 1 0. With this, the first one is x complement y z, right? So this is representing, so this is representing basically the x complement yz. So this is representing m of 3. So m of 3 means this is 1 over here, right? Then x y complement z complement, this is representing m of 4. So this means 1 over here, right? Then we have x y z. So this means this is representing m of 7, so 1 over here, right? And then we have x, y, and z complement. X, y, and sorry, this is representing x, y, z. So this is representing m of 7. And x, y, z complement. This is representing m of 6. M of 6 is 1, 1, 0. Right? Now, if you see what we can do, we can make some vertical group and some horizontal groups. Right? So how we can do that? So if you see this one and this one, they are making a group of two, right? And again, the one over here and this one over here, we can have the horizontal group, right? Because if you see this edge, which is this edge, is actually adjacent to this edge, right? So this edge is adjacent to this edge, right? So what we can do, we can make a vertical group with this as a vertical group and this as the horizontal group, right? Now the vertical group will be represented as, if you see what is not changing, right? So in the vertical direction, x is changing. So we cannot put x in this group, right? So this means the vertical group will be represented as, we have the terms which is not changing is y is not changing and z is not changing. So we will write yz for the vertical group. Are you with me?
Yes, sir.
Right? So if you see what is not changing is y and z is not changing in this group, right? Because x is changing 0 and 1, because in the two adjacent boxes, in one box the value of x is 0, in the other box the value of x is 1. So therefore we will write yz for the group of 2 over here. Then the horizontal group, if you see what is not changing, the z is actually not changing, right? What is the value of z? Z is, z complement is not changing, and then this group will be represented as x into z complement. Are you with me?
Yes,
Yes,
sir.
sir.
Right? So from this, what we can actually deduce, that there are the adjacent boxes in which something is not changing, right? So if you see in these two boxes, y complement is not changing, right? Again, in these two boxes, y is not changing, right? Then, if you see in these two boxes, z is not changing. Let me just write. Z is not changing, right? And in this box, which is adjacent to this box, z complement is not changing, right? Are you with me?
Yes, sir.
So whenever we want to make the group of two, so we can just check what is not changing, and accordingly we can make the respective groups, right? Now let's see another example. We have a function. We have a function equal to, function is equal to let's suppose it is we have the function is equal to summation 1 3 1 2 3 5 and 7, right? We have a function which is summation 1 2 3 5 and 7, right? So this means, and the function has the variables. Let me just write it clearly. So the function has got the variables x, y, and z, right? So the function x, y, z is equal to summation 1 2 3 5 and 7. So what we can do from here, again we will have the 8 boxes because the variables, they are 3 in number, x, y, z. So 0 1 0 0 0 1 1 1 and 1 0. So 1 2 3 5 and 7, right? Are you with me?
Yes, sir.
Right, now if you see, we can either make a group of two, like we can make a group of two like uh, this vertical group, we can make this vertical group, and then we can have a group of two which is an overlapping group, right? Are you right? So we can have two vertical groups and one horizontal group with an overlapping group, right?
Excuse me, sir.
G question.
Sir, here is five main terms will be written in the first column of the last row.
Five main terms.
Sir, you write on a four terms except five.
I write five terms.
No, sir. I mean to say that we write a one on five terms. You write a one on four main terms, sir. Zero one, zero one, two three. Okay, okay, sir. It's right. Sorry.
Is this fine?
Yes, sir. It's right. Or
Okay, G, thank you. So we have five terms and we have filled the five boxes respectively, right? And then we can have the group of two with either two vertical groups and one horizontal group which is an overlapping group. Okay, let's see how we can deduce from here that this the first vertical group, which is this one, the first vertical group, I can write function is equal to, what is not changing over here is y
Y
complement
and
z.
Z.
In the second vertical group, what is not changing is yz. And the third horizontal group, which is basically represented as x complement y, right? Are you with me?
Yes, sir.
Or I can do another thing. I can make a group of four out of the two vertical groups. So if I make a group of four over here, right? Instead of making two vertical groups, I can make a group of four. So in a group of four, what we will see, what is not changing, right? So in a group of four, if you see, what is not changing is only the z which is not changing, right? Are you with me?
Yes,
Yes,
sir.
sir.
Right? So in this group of four, this will straight away be written as z, right? Or from the equation which we have written for two vertical groups and one horizontal group, if you see over here, we have y complement z plus yz. So this means we can take z common. We are left with y complement plus y and plus x complement y, right? What is y complement plus y?
1.
1. So this means we are again z plus x complement y. We are left with this, right? We are left with this, right? So this way we can either make a group of 2, we can either make a group of 4, or if all are ones, let's suppose if all are 1, so this means we can have the function which will be equal to, if every box is ticked as 1, so the function will be equal to 1. Are you with me?
Yes, sir.
Right? Any question up till now?
No, sir.
Okay, Ji. So this is something about the three variable K map, and let's go to the four variable K map. So if we have got four variables in a K map, so let's suppose we have basically the four variables. We say function x, y, w, and z, or we can say wxyz, or okay, let's make it the way it is in the book. So I will just write the way it is because it will be much simpler for you. I will write w, x, y, and z, right? So w, x, y, and z, four variables. So the four variables, this means a total of 16 combinations we can have from the four variables. Okay, just hold on. So a total of 16 combinations we can have. This means we can have from m of 0 to m of 15, right? Okay, some problem with the net, probably. Hmm.
सर आपका स्क्रीन शो नहीं हो रहा.
Just hold on.